Okay, a very common application, early application of calculus is in the path of a projectile. And for one variable calculus, you're always thinking about an object moving in a straight line. So this might be a ball or a bullet fired straight upwards, and we can actually derive an equation for the height of this particle or object at time t, where t is t seconds after the object was thrown. And the initial height is h naught. The initial velocity given in feet per second is v naught in this equation, and the height after t seconds is minus 16t squared plus v naught t plus h naught. Now that minus 16 comes from the force of gravity, and you'll see in calculus why this equation is true. So let's think about a problem here. Suppose a ball is thrown vertically upwards, starting at a height of 32 feet, and with an initial velocity of 80 feet per second. So the ball is thrown upwards, the ground is here, it's from 32 feet above the ground, the ball starts here, goes straight upwards, and then of course due to the force of gravity, what goes up must come down, comes back down to the ground again. And after t seconds, the height is given by ht, which is minus 16 squared, minus 16t squared, plus the initial velocity, which is 80 feet per second, and that should be given in feet per second, plus the initial height, which is 32 feet. And that equation gives us a formula for the height of this ball at time t seconds after it was thrown. The first question is, when does the ball hit the ground, essentially? And we want to translate this into an algebraic question, and so essentially we can rephrase this as, when is h of t equal 0? So let's assume that the ball doesn't bounce, or it's the first time h of t equals 0, and this translates to when is minus 16t squared plus 80t plus 32 equal to 0. So now we have an equation to solve. It's a quadratic equation, and by now we're experts at solving quadratic equations. So we can use the quadratic formula, but the numbers here are a little unruly, so we might do well by pulling out this minus 16 first. We have minus 16t squared minus 5t minus 2 equals 0. And now I could divide across by minus 16, and I need to solve t squared minus 5t minus 2 equals 0. Okay, now there aren't any obvious factors, so I'm going to use the quadratic formula here, and I get t equals minus b, so that's 5, plus or minus the square root of the discriminant, which is b squared minus 4 by 1 by minus 2, all over 2a, which is 2. And that's 5 plus or minus the square root of 25 plus 8 all over 2, which is 5 plus or minus the square root of 33 over 2. And there are two possible values for t here. Either t is 5 plus the square root of 33 over 2, or 5 minus the square root of 33 over 2. And this doesn't seem to make sense given this picture. However, you'll notice that one of these numbers is negative, and so we don't use the negative solution here because we're talking about time, so we're not allowed to go back in time, only forward, so we're going to use the positive solution. 5 minus the square root of 33 is negative because the square root of 33 is bigger than 5. So 5 minus the square root of 33 over 2 is less than 0. So we throw that out. T cannot equal that because t is time. So we conclude that t equals 5 plus the square root of 33 over 2. And then you can use your calculator to figure out that that's approximately 5.37228 seconds if you're measuring up to 5 decimal places. Well, let's answer question 1. So the ball's going to hit the ground after about 5.37228 seconds. What about question 2? Could we figure out when the ball reaches a height of 20 feet? So at what exact time would this ball pass by a marker at 20 feet? So the second question is, when does the ball reach a height of 20 feet? And I can translate this to a question in algebra. When is h of t, the height of the ball, equal to 20? Or when is minus 16t squared plus 80t plus 32 equal to 20? Well, now we have a quadratic equation, and we should bring that 20 over and figure out which t values solve the equation. So that is, what is t when minus 16t squared plus 80t plus 32 minus 20, that's plus 12, equals 0. Well, I can pull out the minus 16 again. It might make the numbers easier, but notice 16 doesn't divide 12. So this is minus 16t squared minus 5t minus 12 over 16 equals 0. Or that's the same as t squared minus 5t minus 12 over 16 is equal to 0, dividing across by minus 16. So I now need to solve this quadratic. And of course, in order to do that, I'll have to use the quadratic formula. First of all, I'm going to cancel a little here, and cancel the 4, and I get minus 3 over 4 equals 0. Okay, I have a equals 1, b equals minus 5, and c equals minus 3 over 4 here. So the solutions are given by t equals minus b, which is 5, plus or minus the square root of b squared, which is 25, minus 4 by 1 by minus 3 over 4, all over 2. And that's 5 plus or minus the square root of 25, minus by minus gives a plus, and then the 4's cancel, and I get 3 all over 2. So t is 5 plus or minus the square root of 28 over 2. And again, I see that if I take 5 minus the square root of 28, I get a negative number. So only one of these is positive, and that agrees with our picture. I have t equals 5 plus the square root of 28 over 2. And that's approximately 5.14575 seconds. So it should for sure be less than the previous solution. It should happen before the ball hits the ground, and it does indeed. And it agrees with the picture we have here. There's exactly one value of t, because this point is below the initial height where the ball was thrown. There's exactly one value of t which solves this equation.